Okay, this is Lafayette High School Functions Trig. This is part 2 of our warm-up exercises that we're using for a test review for Chapter 5, Sections 5.1 to 5.4. And on the last video, we finished off with number 12. Let's look at number 13, just solving for a right triangle using trig functions. Instead of Pythagorean. I can't use Pythagorean here. I don't have enough information. So I have to pick sine, cosine, or tangent. Since I am solving for the side opposite, I would like a trig function with side opposite in it, like sine or tangent. Now, sine requires the hypotenuse, which I don't know. I could do some work and figure it out, but tangent has side opposite and side adjacent that I do know. So I just set up this equation right here. Tangent of my angle is opposite over adjacent. Plug in what I know and then solve. And yes, tangent of 41, this required a calculator computation. Now, it wouldn't require a calculator computation if this was a special angle. Okay, if this 41 degrees, if this 41 degrees, instead of being 41, let's say it was 45, or a multiple of 45, 30 degrees, or a multiple of 30 degrees, then I would need a calculator. All right, so what is the next problem that we did? Okay, so the next problem, tangent of 30 degrees. Okay, so these next set of problems, every bit of this can be done from your unit circle, because your unit circle has all special triangles oriented in all 4 quadrants. Okay, so this is easy. Tangent at 30 degrees, reference angle, first quadrant, 30 degrees. So that's just a 30, 60, 90 laying on its side. So solving this problem is absolutely no different than, let's say, I wanted to find the tangent of pi over 6. This triangle is right on your unit circle. Tangent is opposite over adjacent. This number divided by this number. Do the fraction math, rationalize your denominator, you're good to go. All right, so what about this one? Cotangent of 120 degrees. Okay, that we need to find the reference angle. Okay, so there's 120 degrees. Again, a multiple of 30. It's on your unit circle. So my reference angle is this 60 degrees right here in quadrant 2. So I'm really going to be doing the cotangent of 60 degrees quadrant 2 instead of trying to do the cotangent of 120 degrees. Tangent is opposite over adjacent, so cotangent is adjacent over opposite. Again, this right triangle, I think our blue ones are all multiples of 30 degrees. And actually, what are we looking? 60 degrees. That's actually the green triangles. Anyways, adjacent over opposite. Do the math and do your fraction division. Rationalize your denominator. Tangent and cotangent are negative in third quadrant, so it makes sense that this answer then is going to be negative. Okay, so we just repeat this theme over and over and over again. Cosine of 240, that is the same thing as a reference angle, 60 degrees, quadrant 3, same thing as pi over 3. Okay, cosine is adjacent over hypotenuse. Again, we have that triangle on our unit circle. All right. And adjacent, and on a unit circle, hypotenuses are always 1. You know, so you can just say, oh, that's the same thing as the y coordinate of that point. Great. you're right, and that'll work just fine. 11 pi over 6. Okay, reference angle, pi over 6, fourth quadrant, again on the unit circle. And instead of secant, cosine, adjacent over hypotenuse, it's hypotenuse over adjacent, or I can take the reciprocal of my answer for pi over 6 for cosine. Either method is going to give you the exact same answer. I actually prefer to do it this way because I don't like to think hypotenuse over adjacent. All right. Next problem, 21. Okay. Again, it's all about finding where that reference angle. The negative means I just have to go in the opposite direction. 2 pi over 3s, okay, gives me that reference angle of pi over 3. Fourth quadrant is what I'm going to do. Sine is opposite over hypotenuse. And if you're saying to yourself, well, isn't that just this y coordinate that I have on my unit circle? That is absolutely right. And that's why we designed the unit circle with the hypotenuse of 1. So I can just read the sine of the angle right there. Perfect. And if you want to use your odd property, sine is an odd function, I could have just found positive pi over 3, and there's just put a negative sign in it. Okay, so that's using my even odd properties, which are kind of worthless because I can just go into the unit circle backwards and get the same answer. All right, so we're going to continue this same theme. Okay, now here we call it this periodic properties or this coterminal properties to get my where my reference angle is really where it's all about. So this 22 pi over 3 is really no more than a reference angle of pi over 3 quadrant 3. Now I had to spin around the circle quite a few times to do that. That's with the spiral. Every time I spin around the circle is 6 pi over 3. All right, so when I go around, there's 6. Go around again, there's 12. Go around again, there's 18, 19, 20, 21, 22. All right, and that's how I get to this position right here. All right, which is the same thing as pi over 3 in third quadrant. Again, that triangle is on your unit circle. Cosecant is the inverse of the sine, so it's hypotenuse over opposite. Side opposite of that triangle in third quadrant is negative. Don't forget that negative sign. 495, okay? It's the same story, except I'm switching to degrees. If you want to calculate your coterminal degrees, that's fine. That'll work. This is all, a multiple of 45 degrees. Okay, I can just count around my circle in increments of 45 degrees and get the same thing. But I get a reference angle 45 degrees, quadrant 4 is the same thing as 495 degrees, which is coterminal with 135 degrees. All right, so that's 45, 45, 90. Again, that's what the pink on our unit circle. And that is cosine opposite over hypotenuse. Hypotenuse is 1 on a unit circle. Good to go. All right, arc length formula. Arc length is equal to the radius of the circle times the radians. Okay, you need to memorize that. It's simple. We paraphrase this as x is equal to r theta. Okay, r is the radius of the circle, in this case given. Theta, they tell me, is 36 degrees. It has to be in radians. So I need to take that 36 degrees and I need to convert it to radians. Now I can plug that into my formula, and it says it wants the exact value or wants the answer in terms of pi. So instead of putting it in my calculator, I just leave that pi in there and just reduce it. Okay? All right, big, huge ticket item is you've got to remember this step right here. You've got to use radians in this formula, otherwise it just simply doesn't work. Okay, oh lordy, what do we have here? Oh, tree casts a shadow. Okay, you know there's a right triangle in these word problems. Trees, usually uppy downy things. Shadows are on the ground. Usually the ground is a lefty-righty thing. They intersect to make a right triangle. And we've had a thing like that. Now I got to figure which angle do I want to find out. Well, elevation, remember that's a look-uppy thingy. All right, so if I was at the top of the triangle, that theta would be a look-down thingy. All right, so that is why the angle of elevation is down here and not up here. Okay, so how am I going to solve that? Well, if it's down there, then I know the adjacent and the opposite. So the tangent is what I want to use, and then I would have to compute the inverse tangent. And what would we have to do that? That would require a calculator. And I'm not sure, I don't know if there's a question like that on the test. I don't think there is. Anyways, still good review. And that finishes this up. Thank you.